Okay, this is a 15-minute max video just to provide the instructional time that we missed in the class that just occurred and that discussed Galileo's principle of relativity forms 1 through 4. Okay, what I'm going to do now is just give you an overall sense of what it feels like or looks like or is like to take a midterm exam in Physics 203 at John Jay. Um, as you will have seen now in the Google Classroom, your midterm exam in Physics 203 will be due the beginning of class period, i.e., at 9:25 a.m. Wednesday, October 29th. I'm working backwards now to explain this. That means you're going to come to class, to synchronized remote class on Wednesday, October 29th, and you're going to come to class and sit in class per usual, but you will have turned in your exam, up to a minute before you showed up for class. If you don't show up for class, that means you've neglected part of your exam responsibility. Even though once we start class, we're just going to do class. It won't necessarily be about that exam, but part of your exam responsibility is being in class as though we were taking an exam right there in real time. However, we are not. The exam that you're going to take and turn in will be an exam that will have been posted through Google Classroom no later than Friday evening prior, 8 p.m., October 24th. Right. And by the way, if anything I'm saying here, if any date or time or anything is inconsistent with anything that I posted in Google Classroom, then you should individually let me know and I'll straighten it out. But I believe what I'm saying should be consistent. Um, so a document will be posted no later than Friday evening, and you then have like 5 days to create a document in response, and the document you create in response is your exam. That means a number of things. That means, yes, this is a take-home exam. And no, there's no webcams or anything like it's not synchronized in any way. You're taking home the exam. You're doing it under any conditions you wish. You are doing the exam open universe. I mean, open notes, fine. Open web, fine. Open other people, fine. Okay, seriously. This is a little bit unusual, and that's why it needs to be explained perhaps the first time. Everything I'm about to say right now, or everything I'm saying right now, applies to your midterm exam in Physics 203. It will also, unless there's a chance, unless further notice, it will also apply to your final exam in Physics 203 and your midterm in Physics 204 and your final exam in Physics 204. It's worth getting used to now. So, indeed, what I'm saying so far, you are hearing correctly. You can use any sources or any conditions you wish in order to create the document that you're going to turn in on time for the following Wednesday. This means that the expectations and the grading, of course, must be also somewhat unusual, right? Like I am literally saying to a point, you can help each other try to figure out how to solve the problems that will be posted in the exam on Friday. What that means is clearly you are responsible for far more than just correct answers in the exam that you turn in. you're going to turn in a document that is far more like a presentation or a long paper, or arguably you might even say a research paper. What you're turning in is not a is not a Scantron sheet by any means, right? Or a Google form. What you're turning in is a presentation of thorough solution processes. This is why, and what it'll feel like, what you're doing, what the exam will be like, is a few long problems, much like some of the long multi-part problems that you've experienced in the homeworks. The homeworks are meant to be practice for this experience. The five-step method that you've been practicing on the homeworks is the method, is the skeleton, the minimum condition of the method that you are absolutely expected and required to provide for all your solutions that you're doing on the exam. Again, this is sort of why you've been put through that, through the homeworks. You're going to be asked a bunch of problems. You're going to be giving a fact pattern and asked a bunch of, scaffolded sub questions about that fact pattern, and that will constitute a problem. And then you'll go to the next problem and the same thing. And there'll be like three or four problems on the exam, which will be very familiar in many spots, very similar in many spots to things you've done on the homework or documents you've seen before, but you're going to work through the full solution to these problems in your exam document. The five-step method is the bare minimum of expectation of how you're going to walk me through the solutions to these problems. You are going to know that I know that you could have gone on the web and you could have even consulted AI and you could have talked to your friends and all that. You're going to know that I know that. So, what I'm looking for by the time you give me a document is a final, polished, beautiful, thorough, comprehensive, accurate, and personal presentation of all of the thoughts necessary to get you from point A to point Z on the solution of any given problem. You see what I'm saying, right? In other words, it's no, you can learn this material anyway. You can watch past videos of mine. I certainly hope you do. I mean, videos from this particular class or any other past semester version of this class. You can watch other videos, from this is not a paid advertisement, from academies that rhyme with Ron and etc. And you can talk to your friends and all that. And by the way, I really hope you do. I hope you have study groups and a group chat and all this kind of stuff where I hope you help each other learn and understand the solutions to these problems. Oh, which some of which might even be posted by me, or solutions to very similar problems might even be posted by me or provided in class or seen in a lab period of review, which you may or may not have, or found in past videos, etc. We're going to give you every resource in the world possible to show you how to understand how to solve physics problems. Then the test, the exam, is can you create a full, thorough, neat, very readable, very engaging, long document where you walk through solutions, always and only writing down things that you now understand. The more that you can show that you now, by the time you're writing out this document, personally understand all the thoughts and the steps that are necessary to get from the beginning of a solution to the end of a solution, the more you can convince me, the more that you can convince me that you really get what's going on, the more successful your document will be. Again, the bare minimum that I'm looking for first and foremost is clear steps 1 through 5 for every solution. I mean, do the steps, label the steps, etc. That's a bare minimum. And if you're missing steps, it doesn't matter how correct your answer is, you will lose points. If you have steps, you will gain points. And even if your answer or something is wrong at the end, every step you do, you're gaining points. So it's all about process, like the bulk of points and rewards and so forth, and affirmation. you get is from steps of process. You will find that by the time you get to this exam, I keep saying the 5 step is the skeleton, is the structure, is your guideline to how to do these things. But many of you hopefully will view that, as I keep saying, um, as a minimum, as a skeleton. And what you're going to do to really show me that you really get this material, that it has come through your mind in your personal way, you're going to use different colors in your presentation. You're certainly going to provide diagrams as the steps require, but maybe you're going to have maybe you're going to do like the actual formal physics here in the center of the page, and then have off in the margin annotations of the person, like, and this, I realized this over here, or you might not have thought that, but in fact, it turns out this. Like, you are presenting to me a movie of your mind as it walks through the beginning of a physics problem to the end. The more I can distinguish your paper from your neighbors, like the more I see you actually shine through and think of it your way, but still a correct way, the more different colors or graphic art or, or personal commentary, the better. So you're thinking of this exam as a presentation, I mean, a written presentation. You're thinking of it as a presentation of comprehension and of process, right? You're not thinking of it, and in that sense, it's like a paper or whatever word you want to use. It's like a long essay. And by the way, a huge criterion of the whole thing, as we've been practicing in homework, is it's a self-sufficient document, right? Like you'll get an exam booklet, so to speak, posted Friday evening. Then just like you do with homework, you're taking fresh, blank pieces of paper, whether they be electronic or hard, and you're writing out full responses to the questions that always, particularly in steps 1, and 2, always make 100% clear what the question is that you're answering, and then answer the question and organize it and then move on. In other words, one criterion you should be obeying as you do this document is I I should not need anything next to me in order to follow your document and grade it and see if it's accurate. I shouldn't be needing to look at anything else but your document. It is self-sufficient. It provides a question in your words. It shows that you understand what the question is, and then it answers it, thoroughly. Put another way, I should be able to give your document to anybody else who knows physics, whether they're in this class or not, whether they know the questions. I should be able to give it to someone who knows physics, and they should be able to follow it from beginning to end and know whether it's accurate or not, right? It's a self-sufficient document. It's a presentation. I'm not trying to scare anybody, but I'm saying you have a huge amount of advantages on the one hand, that you do this any way you want, how you want, in your time, blah, blah, with any help you want. But that's the advantage. And that does make it hopefully a more comfortable, less stressful experience. On the other hand, you have to know that I know that by the time it gets to my hands. So what I'm looking for is, at the end of the day, no matter how they got there, do they understand? Are you fluent in the language of physics now? Fluent to the level that we're expecting in this class? Not can you repeat physics knowledge to me, but can you communicate physics thinking to me, to the level that we're at in this class? That's what you're looking for. That's the idea. I'm looking at the time. And so one thing I highly recommend, like, it's not so much about studying for this exam, it's preparing the way you would for a paper. So one thing you'll know you're in the right camp is you're doing this correctly if first you do a rough draft before you do a final draft. If you want to give you, one of the reasons you have 5 days to do this is you want to first start solving these problems on pieces of paper or with your friends or whatever. You want to first start like scrawling out the problems and trying to get correct answers and seeing where you're confused and seeing where you have to look back in your notes or watch videos. That's all fine. That's part of the process. You do stuff, you write things down, but that's all like a rough draft at best, or it's even before a rough draft. Then leave yourself enough time to then, by the time you think you have all the answers and you think you know the steps and you think you know what you're doing, it's not about having to do it closed book. You don't have to do anything closed book, but you have to give yourself time and have your thoughts refined enough that then you present a document that I really want to open and read. Like, it's a final presentation document. You follow me? Um, So if it's hard to follow or everything's squeezed together or the page numbers or things are out of order, not only does that make it much more difficult to assess and be on the receiving end, but it also sort of indicates you didn't really get what this was all about. Okay, so you're presenting me something, each of you is presenting me something that at the end I actually want to read and follow and see, boy, they really know their physics. That's the idea. I'm looking at the time. Um, you will notice that already in the Google Classroom, there is a midterm from last semester. It's not exactly your midterm. It's close. I mean, your midterm would be very much like it. It certainly gives you an indication of what kinds of things you have to know, what kind of problems you're responsible for. The basic topic here is one-dimensional is kinematics. Like your midterm is basically on one and two-dimensional kinematics, constant acceleration, all of that. That's what the exam's about. What's in Google Classroom is a fairly good representation. As we get closer to your actual exam, I may tweak or update that to make it any tweaks or updates I do to that document, the practice document, will just be an effort to make it even more similar to what you can expect on yours. So by the time yours is posted, it will not be a surprise. There won't be any tricks, or not intentional tricks. It'll be very similar to what you can already spend time practicing and trying to learn that's already in the class in the learning portal. Okay, so none of this is meant to be about surprises or anything like that. It's meant to be, do you really get this physics? Um, so if you want to start preparing and studying, the way to do that is to use the document that's already there. Just understand, I may update and make changes to it. Some of the things you still might not know how to do yet because we still have some time before this exam. But start with the things that you feel like do look familiar. Last thing, sometimes I'll even give solutions to that or you may come across, you may find videos where I've actually solved problems very, similar to that. That's great. That's fair game. You can use those solutions. Know that then probably I'm going to tweak numbers or make some changes to your document. It won't be exactly the same as that when yours is posted. On the other hand, there may be certain problems where I've deliberately, where I've never posted a solution that I know. And then maybe the problem will end up being that much more similar in your actual. In other words, I'm not promising that you get solutions to all this in advance. You can find some solutions and some you won't. And the extent to which you can find solutions may determine how similar your actual exam is to the practice. But the bottom line is that your actual exam will be very similar to what you see there in the practice. So most questions you might have, like, is this material on the exam or not? Or do we get equations or not? All that, just look at the practice exam and they will make that somewhat apparent. Um, so that's the overview. That's how we'll talk about it more as we get closer. And the best thing you could do is any day before the exam, come in with specific questions about the practice document and I will answer them. So it's not meant to be mystery, but that's a basic overview. And I will just, I guess, last thing, and for some people, by the way, this type of exam works way better. Like, even if you think you're struggling in physics or you're not sure what's going on yet, in some ways, this will play to your strengths and give you an opportunity to really, especially if you work hard and you care, even if some things are confusing to you, this will give you a lot of opportunity to get it all together and know what I'm looking for before you do it. Others of you who are just used to using like ChatGPT and stuff like that, or to get through stuff, I gotta warn you, like, this won't play to your strengths. It may feel like it's going to, but it won't. I just do want to warn you that I want to caution you that at this stage of the game, the nature of AI now, the nature of most people's relationship to AI and the relationship to and the nature of my relationship with physics, I could tell you from recent experience, as of even the last semester, for it is not illegal to use ChatGPT. I mean, knock yourself out. It doesn't count as cheating in an exam like this. But I will tell you that even last semester, even with ChatGPT, and I don't mean this is not a paid advertisement, whatever AI tools you use, even after the last semester, where they're all fair game. I'm telling you that the grades that came on this exam were a bell curve. Like, lots of people did really well. Most people did in the middle. I mean, like, people got in the 90s, most people got like in the 70s, and a lot of people failed. I'm not saying that to scare anybody, but I am saying just because you can work with other people and just because you can use AI tools does not mean that this thing is a slam dunk. You don't get punished for cheating if you use AI, but I'm telling you right now that it's not good. It won't be good enough to you. It's not good enough to do the kind of physics that I'm asking you to do. I can tell the difference, and it doesn't matter whether I can tell the difference or not, because I'm looking for very specific thought. I'm looking for fluency in physics from each one of you. Assume this is like a foreign language that you're learning, or like a musical instrument that you're learning, more than like a body of information, and assume that I'm fluent in that language. I can tell when I'm conversing with someone who's fluent in my language versus when I can't, for the most part. I mean, obviously things slip through the cracks, but you don't just what you can feed this exam into AI. You can. I'm not saying that's, but I am telling you from experience that won't work as well as you think it will. What you want to do is learn the physics and do the physics and do it with the equations and the principles that we've learned in class. That's what we're looking for, a personal presentation of what we've been learning in class. Okay, so that, and you can do really, really well. And many of you will. And I want you to. It's not meant to trick you. It's meant to get you to be that much more conversant in physics. And many of you will. And even those of you who are worried or nervous or think you're not in grips with physics, this will give you an opportunity. You'll find yourself getting better at physics, even undergoing this exercise, if you do it honorably. So may the net force be with you.